So we are going to learn data link layer. Data link layer is the second layer of OSI model, which is majorly responsible for framing, error control and flow control. In this session, we are going to learn flow control mechanism of data link layer. So error control and flow control mechanism are the major parts. So we have got three major protocols: stop and wait, go back and ARQ, selective repeat ARQ. In this session, we are going to learn go back and ARQ. So in go back and ARQ, the sender can send up to W frames without worrying about the acknowledgement. If it does not receive the acknowledgement, it will keep all the frames and it will resend in two cases. Once if it does not receive any acknowledgement and the timer is out. So this procedure is an additional procedure which was not there in stop and wait, but we have got in go back and. So now we move on to sequence numbers. Frames of the sender are numbered sequentially. We need to set a limit. We need to include the sequence number of each frame in the header. Suppose the header frame allows m bits. If you can see here, we have got m bits. If the value of m is 3, so 2 to the power of 3 would give me 8. 8 minus 1 is 7. So I can number my frames from 0 to 7. So there is a possibility that I can have more than 7 frames. In such situations, the frame numbers are repeated again in sequentially. Suppose after 7 again you have got 7 frames, then you will number again 0, 1, 2, 3, 7. Again you have got more than 15 frames. Again this procedure goes on. Now we'll move on to see what happens in the sliding window. So the sender and receiver has got a window. So now we'll talk about the sender sliding window. If you can see here, if the value of m is 3, so you have got 2 to the power of m minus 1, that is 7. So your window size is 7. Inside 7, you have got 7 frames numbered from 0 to 6 initially. Once the receiver receives frame 0, the slider will move to the right and your new sliding window will have the values 1 to 7. If 1 is also received, then the slider will again move, then your value will be from 2 to 0, which is shown here. After sliding 2 frames, this is your window size. Now you can see that the window size is always fixed, but this is not the case in case of TCP. In TCP, the sender window size is always variable, which depends upon the congestion of the network as well as the buffer in the receiver side. So this is about the sender sliding window. Now we can move on to the receiver. In the receiver, it is very important to note that the receiver side in this protocol has always got the size of the window as 1. So if inside the window of size 1, if the frame 0 is there, it means that the receiver is expecting 0 to arrive. Once it receives 0, the slider will move to 1. This means that it is expecting 1. This is how it works. So now we'll take an example. Now see control variables. There are 3 variables here: S, SF and SL. S holds the sequence number of recently sent frame. SF holds the sequence number of the first frame. SL holds the sequence number of the last frame. Receiver has only one variable R that holds the sequence number. Suppose here you have got R equal to 0 and it is sending 2. So if 2 is being sent, it was expecting 0, it will discard. And meantime, if the timer goes off, then it will send entire thing which is there inside the window. That is 0, 1, 2 will be sent again, which will be seen in the next example. Here the important point is about the acknowledgement. Receiver only sends the positive acknowledgement. It means that if it receives the data properly, it will give you an acknowledgement. If the data are damaged or lost, it will not send you any acknowledgement. Suppose this was what I was explaining. Suppose the timer goes off after frame 3. Then inside the window it will send back again 3, 4, 5, 6. Again it will send back. This is go back and ARQ. Here the important point to be remembered is it is not necessary that after every frame you send an acknowledgement. You can either send a cumulative acknowledgement, and another very important point is acknowledgement are never resent. This is what you need to remember. Acknowledgement are never resent. So now we'll see a normal operation. Suppose your window sizes of 3, 0, 1, 2 are the frames which needs to be sent. Frame 0 is sent, 0 is received. Once it receives, it will slide to 1. It means that it is expecting 1. If you can observe, I have not sent any acknowledgement after 0. It is sending cumulative acknowledgement. So cumulative acknowledgement 2 is being sent. It means that the sender assumes that 0 and 1 are received intact and it is expecting 2. Frame 2 is sent. 2 is received here. it will slide and send acknowledgement 3, frame 3 is received. This is the normal operation. But this is not always the case in real scenario. You can have frame being lost, you can have acknowledgement being lost. All these cases are to some extent very effectively handled by Go Back and ARQ. So now we can see the case where frame is lost. So in this case, 0 is sent, frame 0 is sent, 0 is received, the slider moves to 1, it is expecting 1, frame 1 is sent, and now it will move to 2 and send an acknowledgement to telling that 0 and 1 have been received, and it is expecting frame number 2. So in here, as 2 frames are properly received and it has got an acknowledgement, the slider moves and inside the slider I've got 230. So now if you can observe, frame 2 is being sent. Now frame 2 is sent and it is lost. Okay. So now the receiver has not sent any acknowledgement, because after sending frame 2 in the window it has got frame 3, it will send frame 3. Because it was expecting 2 and frame 3 has arrived, it will discard. So meantime, if the timer is out and inside the window I have got 230, it will again send 2. So once it sends frame 2, it was expecting frame 2 and it will receive frame 2 and the slider will move, acknowledgement 3 is sent and frame 3 is resent. This is how it functions when the frame is lost. Now we'll move on to Go Back in ARQ when the acknowledgement is lost. So there can be two situations. If the acknowledgement arrives before the expiration, there is no need for retransmission. If acknowledgement 1, 2, 3 are lost and 4 covers them, it arrives before the timer expires. If the acknowledgement 4 expires, the last frame, all the frames after that are resent. Here the important point and the last point is very important to be remembered, that receiver never sends any acknowledgement. The same points we can see through an example. So now we can say there can be a situation where we can have a window size. So it's a common question that why should the window size should always be less than 2 to the power of m? Why cannot I have a window size greater than that? We can take up the two scenarios and explain this. So here the important thing is the size of the receiver is always 1 and the size of the sender window must be less than 2 to the power of m. So if I take m equal to 2, so I have a window size of 3. So now I'll take two examples of 3 and 4. So now this is the proper way because 2 to the power of m is 4 and 2 to the power of m is 4 and my window size should be 3. This is alright. So now we'll just see an example. So frame 0 is lost. Frame 0 is sent, 0 is received and acknowledgement is lost. 1 is sent, 1 is received, acknowledgement is lost. 2 is sent, 2 is received and acknowledgement is lost. So in this case, the sender has not received any of the acknowledgement and the timer is out. If the timer is out, so it will resend whatever is there inside the window. So frame 0 is sent, but it was expecting 3 because 0, 1, 2 it had received. So 3 it was expecting and it has correctly discarded. This is how it properly functions if your window size is less than 2 to the power of m. Suppose my window size is equal or greater than 2 to the power of m. This is the case where I have taken equal because my m value is 2. So 2 to the power of m is 4. So my window size is 4. This is where the case where the window size is equal to 2 to the power of m. So if you can observe the same scenario, frame 0 is received, acknowledgement is lost, frame 1 is received, acknowledgement is lost, frame 2 and 3 are received and acknowledgement is lost and the timer is out. So in this scenario the same thing happens. Inside the window, whatever frames are there, it will resend. So now after 3, because it had received all the 3, it is expecting 0 of the second cycle. But because the acknowledgement was not received, it is sending 0 again. But this 0 is of the first cycle. So frame 0 is sent, but it is a wrong frame 0, which it erroneously accepts it. This is where it goes wrong. So this is why it is always advisable to have a window size less than 2 to the power of m. I hope I have covered all the topics related to Go Back and ARQ. Thank you for watching.